Okay, in this session, I'm going to cover step 3 of GED Math. The topics data analysis, statistics, and probability. So the first we are going to cover statistics, okay? So what do we mean by statistics? So it is just a data summary. So you have collected the data, you want to summarize the data in a meaningful way, you can present to people, okay? So we generally use mean, median, mode, range as the measures for summary statistics, okay? So let me start with an example. So let's say that I've got a math class and I've got 7 students in my class, and the last math test, these are the scores, okay, the 7 students. Each student, the first student got 78, the next student got 98, the next student 82, next student 85, next student 90, next student 78, next student 79. So now you are asking me the question, hey, how is your class doing? Okay, how was the test? So then I cannot blurt out to you, oh, these are the scores, 78, 98, 82, it won't make any sense to you. So if I just summarize the information, for example, average or the mean, it's a common sense measure, right? I am adding all these scores, 78 plus 98 plus 82 plus 85 plus 90 plus 78 plus 79, adding all the scores of all the people, divide by the number of people, 7 people, then that is the average, 84. So I can tell you the average score in my class is 84, so my class is doing good. So then it'll make sense to you instead of all these individual data points, right? So that's the whole point of doing this computing summary statistics. So this makes sense to you, the mean or the average, right? So another measure, summary statistic we use, it's called median. So median means that you need to arrange the data in the increasing order. So I put in 78, 78, 79, 82, 85, 90, 98. So these scores, I'm just putting them in the increasing order. And then I take the exact middle value. So it's a 1, 2, 3, 4, 5, 6, 7. So I take the middle one. So there are 3 data points to the left and 3 data points to the right, and then I take the middle one, and that's called the median. Okay, so what does that really mean? So when I sort the data from low to high, so this tells me that half the class or 50% of the class have got scores more than 82, and half the class or 50% of the class have got scores below 82. So it's right in the middle, okay? So that's another measure called median, okay? And then another measure called mode. Mode is the most frequent data point. So if I look at this data, which data points happened most frequently? So if you look at the score of 78, two students out of 7 got 78. All the others, each other student got a different scores, okay? So the most frequently happening score is 78. So I will say that the mode is 78. Okay? That's another measure. So it's most frequently happening measure. And then the range is, the range means the low to high range. So the lowest score is 78. The highest score is 98. So the range is 98 minus 78, that is 20, okay? So the range tells me how wide the range is. So from low to high, what is the difference, right? All these other things, mean, median, mode, they are telling me roughly the center or where the average of the center is. But the range tell me how my spread is in the data, right? And these summary statistics are very, very useful. You see that every day in the TV, in the newspaper, you see that, NFL, for example, quarterback. So if you ask how well this quarterback is doing in the Chicago Bears, then you don't blurt out, okay, so far I've got 5 games, each game, he did, 100 yards, 200 yards pass, he did that. Instead of saying that, what they normally tell you is the average. So far, based upon the 5 games, the average passing is 200 yards. That's his average, passing yards, right? So they summarize the data, and you hear that all the time. Similarly, another example, the median, for example, is used to summarize the house pricing information. So in Peoria, Illinois, for example, what is the median house price? In the median house price, let's say it is $40,000. So what that means is that 50% of the houses in Peoria have got more than $40,000 price, and half or 50% of the houses have got house price less than $40,000. So the median price tells you exactly what the middle is. Half the houses are above that, half the houses are below that, right? So in every day in the TV and newspapers, you see these mean, median, mode, all these statistics given to you to summarize the information so you know something about that topic, okay? So there are other ways to summarize the data, and you can use graphs and charts. Again, you see in the TV, you see bar charts, you see pie charts, different charts and graphs you see. So the next session, we are going to cover how you would summarize the data using charts and graphs, okay? Okay, we are going to discuss some graphs and charts, in this session. So let's start with the first one. This is called pictograph, where you do have pictures. And in specifically this pictograph, it gives you the number of apples sold by the store in a given day, okay? So all these charts and graphs are summary information of some data. So in this specific case, these are the apples sold by a store. So that's what this is, okay? So then in a pictograph, the first thing you want to see is on the bottom, you want to see what that picture means, okay? So here, this is called the key, or sometimes it's called legend. So what this means is that it says that one picture of apple, that's equal to 10 apples, and half an apple means that it's 5 apples. So the way you interpret this, the red delicious apples, how many red delicious apples they sell in a given day? And it is 10 plus 10 plus 10, 30 apples. Golden delicious apples, how many did they, do they sell every day? So you see 10 plus 10 is 20 plus 5, 25 apples. How many red Rome apples do they sell in a given day? 10 plus 10 plus 10 plus 10, 40 apples. How many Macintoshes they sell in a given day? 10 and 10, 20. How many Jonathan apples they sell in a given day? It's a 10 and 10 and 10, 30 plus 5, 35. Okay? So then the question in the exam, in the test, they will ask how many Macintosh apples do they sell in a given day? You can say it's 20. How many they sell in a week? Then it is 7 times 20, 140. Then they may ask a question like how many more Red Rome apples than Golden Delicious apples do they sell in a day? So it's Red Rome is 40 apples, Golden Delicious 25, so 40 minus 25, 15 apples, right? So it's very easy to interpret these kind of charts, okay? So the next, this graph is called the line graph. Generally on the line graph on the y-axis, you will have in this example, this is the number of cars sold by a dealer, okay? So this is the dealer sales, okay? On the y-axis, you'll have the number, something like that. On the x-axis, you will have like a month or year or something like that. So with the line graph, you will be able to see the trend. If the car sales is going up or going down, you'll be able to see that. And in order for you to interpret this, in January, the dealer, how many cars did the dealer sell in January? So you go up in January, and then you go across, and you see that there are 20. So he sold 20 cars in January. And then February, and then you just go up there, so that's a point, and then go across. So 35 cars in February. And then March, you go to March and then go across. That's 25 cars in March. Then April, you go here, April, and then go up, then go across 40 cars in April. And then May, you go up here and then go across 45 cars in May. And then in June, if you go across, it's 30 cars in June, okay? So during which month the dealer sold most cars in May? Or during which month the dealer sold the least number of cars is January. So he sold only 20 cars in January, but in May he sold 45 cars. Then what is the average number of cars sold per month? If you want to find the average, then what you need to do is look at the sales number of cars in every month, like in January 20 plus 35 plus 25 plus 40 plus 45 plus 30, add those, and then divide by 6, so 32.5. So that's the average number of cars sold per month is about 32.6, okay? So let's move on to the next chart, and this is called the bar chart. So in the bar chart, again, on the y-axis, here, we've got the number of visitors in thousands, visitors to a park. On the x-axis, we have years. In the previous chart, we had a month, January through June. In this case, we have 1995, 96, 97, 98, 99. So it's very easy to interpret the chart. So in 1995, you go across, then you see 20,000 visitors in 1995 to the park. Then 1996, you go up, go across, 40,000 visitors in 1996. In 1997, there are 60,000 visitors, okay? And then 1998, there are 50,000 visitors. Then 1999, it's in between, so it's about 35,000 visitors in 1999, okay? So then just as soon as you look at the chart, then you will know which year has the least number of visitors. So immediately you know that 1995 has the least number of visitors. And then which year had the most number of visitors? You will know that 1997, most number of visitors, 60,000 visitors, okay? And then how many more visitors were there in 1996 compared to 1995? So, then 1996 versus 1995. So 1996, there are 40,000 visitors. 1995, 20,000 visitors. So there are 20,000 more visitors in 1996 compared to 1995. Okay? So then if the question asks for the total number of visitors in all the years, then you can actually add up 20,000 plus 40,000 plus 60,000 plus 50,000 plus 35,000. You will be able to add those and say what is the total number of visitors in all the 5 years. Okay? So now let's move on to the next chart. So this is also bar chart, but there are multiple bars here, right? So there are 3 different colors. On the y-axis, it's a percent literacy. That's the y-axis. On the x-axis, you've got different continents. And then there are 3 bars for every continent. And then again, up at the top, you see the legend or you see the key. It tells you the gray color means that it's total. Blue means it's males only. And pink means it's female only. So if you see Europe, if you go across, you see that in Europe, overall total 90% literacy rate. Males and females also 90%, 90%. So it's the same for Europe. Then North America, also overall literacy rate total is about 90%. And for male, it's slightly little bit less, 89, something like that. And for females, it's a little bit more, 91%, something like that, right? So you can see that. And then South America, overall, if you look at the gray bar, so you need to go across. So that's about 78% literacy rate. And then in South America, if you look at the male, so if you go across, that's about 85%. And then South America female, so you just need to go across, that's about 75%, okay? Then Asia, the total, so the gray bar, if you just go across, that's about 75%. But then if you look at the male, so you just take the top of that, so that's 85%. And then look at the female, so you go across, that's about, about 65%. Then Africa, overall literacy, the gray bar, so you just keep going across, that's about 72%. But then if you look at the blue bar, that's about 85%. And then the pink bar, the female, that's about 60%. So you can actually see the trend, highest literacy is in Europe and North America, and then a little bit down for South America, a little bit more down for Asia, a little bit more down for Africa, okay? And then which continent has the least female literacy, and that is Africa. So and then if you go across, then you will know the percent, so that's about less than 60% female literacy in Africa. And which continent has the least male literacy, so that if you compare the blue bars, I mean, these are about the same, but South America seems to have a little bit less, so that's about, 85%, okay? So it's very easy to interpret these charts. Okay, the next one, this is called line chart. So the line chart, here they will have a mark like X. And then this is the data of the children who attended the summer camp, okay? And so each X here denotes one child, okay? So for example, by looking at here, you can see that there were 3 children at age 5 in the summer camp. And then you can see age 6, 1, 2, 3, 4, 5, 6. There are 6 children of age 6 were in this camp. And then there were 4 children of age 7 in this camp, and so on, right? And then there were 2 children of age 12, in this camp, okay? So then how many children attended the camp? So you just need to, each X is a child, so you just need to count 1, 2, 3, and then 4, 5, 6, 7, 8, 9. Like that you count all the X's, and that comes out to be exactly 45. So 45 children attended this camp, okay? And then the question they may be asking, how many 12-year-old attended the camp? You just say 2. How many 10-year-old attended the camp? Then you need to count 4, and then plus 4, and then plus 1, 9. So 9 children attended who were age 10, okay? So let's move on to the next chart. And this chart is called the frequency table. And this data represents the marks. Marks means that scores, right? Score or the points or the marks mean the same thing. How many marks or points they received in a test by 3rd grade children in a class, okay? So mark 1 means a 1 point here. And usually, when you are counting from the raw data, you will be doing the tally marks. Tally marks, the way you normally do, you put 4 for each child, you start putting a line. Then after you're done with the 4 line, the 5th one you put across. So then, this tally marks means that you've got 5 children here. And then next child, you just start putting, the vertical lines. Once you are done with 4, the 5th one you will go across. So then when you do the tally marks this way, it's much easier to count. So the frequency or the number of children, 5 plus 2, 7 children. So 7 children got a score of 1. 5 children got a score of 2. 6 children got a score of 3. 5 children got a score of 4. 3 children got a score of 5. And then the total number of children in this class is, if you add up all these frequencies, that's a total number is 26. So you know that in this class there are 26 students. Then how many children did receive 5 points, 5 marks? And 3 children got exactly, 5 points, okay? And what percent of students received a mark of 3 points, okay? So 3 marks, there are 6 students, right? So if you want to calculate the percent, 6 out of 26, right? 26 is the total number. 6 out of 26 times 100. So 23% of the class got a score of 3 points. Okay? So the next chart, this looks like a bar chart, but this is called histogram. The reason is that the bar chart before, on the x-axis, we saw the years in the bar chart, right? Or we saw the continent. You know, we have some kind of categories on the x-axis before. Those are called bar charts. The reason this looks like a bar chart, but this is called histogram, is because on the x-axis, we have the actual data, right? We've got a lot of numbers. So we don't have categories like continent, you know, Asia, America, like that. So whenever you have actually numbers, data on the x-axis, and then you have a bars, then it's called a histogram, okay? So this data here on the x-axis, what is the data? It's a reaction time of teenage drivers when driving a car, okay? So now you can see that there is one teenage driver who was able to react very quickly. Within 0.25 seconds, that person was able to react. That's on this side. But on the other extreme side, there were one teenage driver. It took 0.8 seconds for that person to react. So all the other people were in between, okay? On the y-axis, it's frequency, so the number of teenage drivers. So if you look at 0.55, and if you go up and then go across, that's 8. So what does that mean? 8 teenage drivers had a reaction time of 0.55 seconds, okay? And let's take this 0.65. If you go across, it's 2. So 2 teenage drivers had a reaction time of 0.65 seconds. And 1 teenage driver had a reaction time of 0.8 seconds. 1 teenage driver had a reaction time of 0.75 seconds. 1 teenage driver had a reaction of 0.25 seconds. Then if you look at 0.50, if you go up across, that's 6. So 6 teenage drivers had a reaction time of 0.5 seconds. And here it's 7 if you go across. So 7 teenage drivers had a reaction time of 0.6 seconds. Okay? So that's the way you interpret the histogram. And then since the frequency is there, so you can actually count how many teenage drivers are there, and you will see that it's 35. And what is the maximum reaction time? That's 0.8 seconds. And what is the most frequent reaction time in a histogram? The most frequent time is going to be the tallest bar, because that's a frequency. The most means that it's the tallest bar. So 0.55. So the most frequent reaction time is 0.55 seconds. Okay? So then let's move on to the next chart. This is called the scatter plot. You've got just a bunch of points here. So this data is miles per gallon versus car weight in tons. So on the y-axis, you've got a miles per gallon. On the x-axis, you've got the weight of the car. And each dot here represents one car, okay? So in the scatter plot, what we normally do is we take a car and then we measure 2 things on the car. So we actually measure the weight of the car, and then we measure how many miles per gallon that car provides, okay? So each dot here is a car. So for example, let's take this one dot here. If you look at the dot, if you keep going down here, so that is about, it's less than 2, it's about 1.5 tons, right? So on the car weight for this particular car, that's one car, its weight is about 1.5 tons, 1.5, and then miles per gallon is about 30 miles per gallon. So another car is very close, it's a little bit on the right side, so it's 1.6 tons in terms of weight, but then about 30 miles per gallon. Then you take the next car here. So if you go across, that's about 35 miles per gallon. And then when you keep coming down, so that's about 1.8 tons of weight, but it provides 35 miles per gallon. So each point you have got, it's like an ordered pair you do in algebra, right? So you've got the x value. In order to get the x value, you need to take that point and then come down. That's your x value. And then you go across, that's a y value. So that's the ordered pair x comma y, and that's what the scatter plots usually do, okay? So and then if you look at this car over here, so if you go down here, so that's a little over about 5.2 tons, that's a weight. And then if you just go across that point, so that's about 15 miles per gallon, okay? So how many cars are there? So each dot is a car. So if you count the number of dots, that many cars are there in this picture, okay? And then if a car weighs 4 tons, how many miles per gallon would you get approximately? So when you have 4 exactly, 4 tons, and then you go up, and then so this car is about 4 tons, and then go across, so that's about 17 miles per gallon, okay? So for a 4-ton weight car, the miles per gallon is about 17, okay? So then another question is, what is the maximum miles per gallon would you get? So that means that maximum miles per gallon is way up at the top here, right? So that is about 35 miles per gallon. So that's the maximum miles per gallon. And then what is the minimum miles per gallon would you get? So that, if you just look at these 2 points here, so this, if you just go across, that's about 10. So 10 miles per gallon is the minimum, miles per gallon, okay? So let's move on to the next one. So this is called the pie chart. So the pie chart is very similar to the bar chart, but then in the pie chart, we usually use a circle. So in this case, the data is the student grades, from a class, student grades are represented in this pie chart. So what this says is that A means that 4 students got a grade of A. That is represented by this green piece here, okay? And then it says that 14.3%. So 14.3% of the class got a score of A, or you can say 4 students got a score of A, okay? Then if you go to the next, to the purple part, that's a big one, and here there are 12 students, they got a score of B, right? And in terms of percent, 42.9% of the class got B. So in the pie chart, generally they give you the percent, and sometimes they give you the number also, okay? So you can interpret this, the purple piece as 12 students, this part represents 12 students who got a B, or it's 42.9%. So that means that if the whole pie is 100%, then this piece of the pie represents 42.9%, okay? So then the red part here, so that is the whole area is 100%. Then this red part is 35.7%. So the way you interpret that, 35.7% of the students in this class got a score of C, or you can say that 10 students in this class got a C, okay? And then the little blue part here, that is D. So 2 students got D, or this area, the blue part is 7.1% of the class got D, okay? So if you look at actually how many students are there in the class, they've got 4 people here who got A, plus 12 people who got B, plus 10 people who got C, plus 2 people who got D. So there, if you add up all the numbers, there are totally 28 students in this class, okay? And then if you actually compute the percents. For example, out of 28 people, how many people got A? 4 people got A. So 4 divided by 28 times 100, if you do that, that will be equal to 14.3%. Okay. Similarly, B, 12 out of 28 students got B. So 12 divided by 28 times 100. So 42.9%. So you will get that. That's equal to 42.9%. So that's how you get this percent. Similarly, for C, you got 10 students out of 28. So 10 divided by 28 times 100, that will be equal to 35.7%. And then similarly for D, if you take 2 out of 28 students, so 2 divided by 28 times 100, that will be equal to 7.1%. Okay? So the kind of questions in the test they will ask, how many students were there, you can answer 28. What grade did most of the students received? Okay, so the biggest the piece of the pie is B, right? So you can visually look at it and see that the most of the students actually got the grade of B. Okay. Then what percent of students got D? Then you can say that 7.1% got D. Then what percent of students received a grade of either A or B? Okay. So you know that 14.3% got A and 42.9% got B. So A or B means that it's 14.3% plus 42.9%. So that is 57.2% of the people received either A or B. Okay? So all these charts and graphs are very, very easy to interpret. So you need to practice more and more problems from your book. You practice, so then you will have a pretty good feel how to answer these kind of questions. Okay? Okay, so the next topic we are going to cover is the probability under step 3. And just let's start with a simple example. Let's say that I'm throwing a die. Okay, so that's an action. So I'm just doing something, right? So when I throw a die, I'm going to get some kind of result. When I do something, I'm going to get a result, right? The results are outcome. Okay, so when I throw this die, what are all the possible outcomes? I can get either a 1 or 2 or 3 or 4 or 5 or 6. I could get any one of those. So if I ask you, hey, what do you think is the likelihood that I'm going to get exactly a 3? When I throw this die, what is the likelihood that I'm going to get a 3? Then intuitively you will say that, there are 6 possible faces on the die, and each one of them, is equally likely. So common sense, you would tell me the probability is 1 out of 6, or the likelihood. So there are 6 possible numbers, and I'm going to get one of those. So probability that I'm getting a 3 is 1 out of 6. Intuitively, that's what you are going to say, right? So let's take another example. So I've got a quarter here, and I've got a head, I've got a tail. I toss the coin. I'm asking you, what is the likelihood that I'm going to get a head? And intuitively, with common sense, you are going to say, either I can get a head or tail. There are only 2 possible results or outcomes. And then the probability that I'm going to get a head is 1 out of 2. Okay, you can say 1 out of 2 or 50%, it's the same thing. Okay, so the probability, so now you kind of understand the idea of probability. It's the same as a likelihood. So every day in real life, they say, okay, today the likelihood that it's going to rain is 50%. Tomorrow the likelihood it's going to snow is 80%. So what that means is, what is the likelihood of that event or the result is going to happen? Right? So that's what they're saying. And so the probability is always going to be between 0 and 1, right? If you do it as a percent, 0% to 100% or 0 to 1, right? It's a fraction. So what do I mean by probability 1? So for example, I toss this coin. So I'm going to get a head or I'm going to get a tail. It's not going to stand on this edge like this, right? So this probability that it's going to happen, it's going to stay, fall on the edge is 0, right? It's not going to happen. So if it's an impossible event, okay, so if an event is impossible, then the probability of that is 0, okay? And then a sure event, if the event is going to happen for sure, the probability is 1. So for example here, either I'm going to get a head or I'm going to get a tail. So if I ask you, what is the likelihood that I'm going to get a head or tail, you'll say, duh, you are going to get either one of those, right? So that's 1, probability 1, right? For sure you are going to get that. So what is the probability that the sun is going to rise in the east tomorrow? You'll say, duh, it's 1, for sure, right? That's 1. And if I ask you, what is the probability that the sun is going to rise in the west tomorrow? You'll say, no, it's never going to rise in the west. That probability is impossible. It's 0, right? So the two bookends are 0 means it's impossible probability, right? And then sure thing, probability 1. Those are the two bookends. In between, the probability is going to be anywhere between 0 and 1. And generally, we express it either as a fraction like this or as a percent, okay? So now, another terminology. So now you have a basic understanding of the probability. And the event means that it's a combination of outcomes. For example, I'm throwing this die, and I'm asking you, hey, what is the probability? Usually we just say P for probability. What is the probability that I get an even number? Okay, I'm asking you that. So then you know that so either 1, 2, 3, 4, 5, or 6, even number means that either I get a 2, or I get a 4, or I get a 6, right? So common sense, you will say, either 2, 4, or 6. So there are 3 possible ways you can get that. So 3 out of 6. So common sense, you will say the 3 out of 6, right? So there are 3 even numbers, and then totally there are 6 possible numbers. So 3 out of 6. Similarly, if I ask you, hey, what is the likelihood that I'm going to get an odd number? So that's either 1, 3, or 5. You will again say that is 3 out of 6, okay? So then you normally reduce it to the lowest term, 1/2, or you can also say that it's 50%, okay? So, so that's all the basics of probability you need to know. You know, when you do an action, you are going to get an outcome of the result. And then the event is the combination of outcomes, and then the probability means a likelihood, okay? So now let me explain a little bit more. So when I toss this coin, so this doesn't mean that I toss one, I got a tail. Second time, you know, I got a head. You know, it's not the way that's going to work, right? So what this means that 1/2 probability of getting a head is 1/2. So if I just say that, probability of getting a head is 1/2. Intuitively, you told me that. It does not always mean that, you know, first time I tossing, I get a head, second time tossing, I get a tail. That's not the way that works. But if I keep tossing the coin like this, so let's say keep on tossing, every time I'm looking whether I'm getting a head or tail, I keep doing this. So let's say I did this 1,000 times. So then intuitively, you know, common sense, you will be able to see that out of 1,000 times, 500 times I would have gotten a head, 500 times I would have gotten a tail, right? So probability means that if I keep repeating that action over and over and over again, and the probability that I'm going to get head is exactly 50% or 1/2. Similarly, probability of getting a 3, just because I throw a die, you know, 6 times, not exactly every time. First time I get a 1, second time I get a 2, third time I get a 3. That's not the way that's going to happen, right? So if I keep tossing the die maybe 600 times, 100 times I'll get a 1, 100 times I'll get a 2, 100 times I'll get a 3, and so on, right? But in order for you to compute the probability, so you don't want to go waste your time and keep, you know, tossing this, you know, coin, you know, 1,000 times. You don't want to do that. So the common sense, what we talked about before, if you just see, you know, if there are only 2 possible outcomes, either head or tail. So you put that on the bottom. On the top, there is only one head, so 1 out of 2. So intuitively, with common sense, you can see that you don't need to repeat that experiment, even though that's what the probability means. But in real life, you just count the, in this example, we count the total number of possible outcomes. That's 6 on the bottom. On the top, if you want to get a 3, you put a 1. On the top, if you want to get an even number, there are 3 possible ways you can get even numbers, so you put 3 on the top, right? So there's a top and the bottom. Bottom is the total possible outcomes. Top is the number of favorable outcomes, right? So that's what we have done here. So now let's take another example. And this example is a little bit more complicated than this. So for example, let's just take this. Let's say I'm tossing 2 dice here, okay? White die and a red die, okay? Now I want to know what are all the possible results, right? So in this case, the white die, I can get all 1 with a possibility, and then the red die can have 1, 2, 3, 4, 5, or 6. Any one of these can happen. Similarly, I can have a white die 2, red die can have 1, 2, 3, 4, 5, 6. Or the white die 3, and the red could be 1 through 6, and so on, right? So if you look at these, how many possible results or outcomes? We count 1, 2, 3, 4, 5, 6, then 7, 8, 9, 10, 11, 12, and so on. 6 times 6 overall, there are 36 possible outcomes, right? So when you actually roll 2 dice, so then, okay, so let's write that down here. So whenever you are rolling 2 dice, you are throwing 2 dice, right? You are rolling through 2 dice, and then outcomes or results, I just showed you there are 36 possible outcomes, right? 36 possible outcomes. That's the total number. So now, let's take that total number of possible outcomes, and then let's say that, I want to know what is the probability that I'm going to get a sum of exactly 3. So I'm adding the 2 numbers on the 2 dice. What is the probability that I'm going to get exactly a sum of 3? So when you look at this, so I can get 2 on the red die, 1 on the white die, right? Or I can get 1 on the red die, 2 on the white die. There are 2 possible outcomes. I could get a 3, right? Let's say I want to have a sum of 4. So I'm asking you what is the probability that I'm going to get a sum of 4. Then you look at it here. So I can get a 3 on the red die, 1 on the white die, or 2 on the red die, 2 on the white die, or 1 on the red die, 3 on the white die, right? So there are 3 possible ways I can exactly get a sum of 4, okay? So now we can actually write down what is the probability that I'm going to get a sum of 3. So we just saw that either I can get 1 and 2 or 2 and 1, right? So the probability that I'm going to get exactly 3 is there are 36 possible outcomes on the bottom. On the top, 2 possible ways I can do that, 2, 1 or 1, 2, based upon the color of the die. Similarly, what is the probability that I'm going to get a sum of 4? We just saw that I can get 3, 1 or 2, 2 or 1, 3. So there are 3 possible ways. So 3 out of 36 and so on, right? So whenever I'm rolling 2 dice, then what I need to do first is that how many possible outcomes, total possible outcomes I'm going to have. Out of that, how many are favorable to me, if I want to get a 3 or if I want to get a 4, right? So now with that, let's define, so far we have done the basics of what the probability or the likelihood is, and now let's define the probability. So The probability, so in this, I have given the exact definition. So how do you actually compute the probability for the problems? So the probability is defined as on the bottom, so you need to have the total number of possible outcomes. Okay, so you always need to find that out, right? So that's what we have seen so far. So if a 2 dies at 36, so you put 36 on the bottom. Then on the top, number of favorable outcomes. Okay, so that's how we define the probability, and we will do some examples. So let's say I have a deck of cards. Okay, so I've got 52 cards. Then I want to know what is if I'm going to draw one card out of these 52 cards, and the question is, what is the probability that that card is a heart? Okay, that's a question. So it's a word problem. If I take one card out of a deck of cards, what is the probability that I'm going to get a heart, right? So it's always, there is a top, there is a bottom for probability, right? So on the bottom, the total number of possible outcomes. So in this case, I've got 52 cards. I can pick any one of those 52, right? So the total number of possibilities is 52. Just like the way, I got a head or tail, I've got two possible outcomes in the coin. In the card example, 52 possible cards on the bottom. On the top, there are 13 heart cards. So the number of favorable outcomes are, there are 13 heart cards, so I can pick any one of those. So 13 out of 52, that's the answer. So 1 out of 4. Or I can also say that there is a 25% chance that I'm going to get a heart. Okay? So then, so let's say that I want to know, I'm just taking one card. I want to know what is the probability that I would not get a heart, right? I don't want to get a heart. What is the probability that, I don't get a heart, okay? So you can think of that in two ways, right? So I already have said there are 25% probability that I'm going to get a heart, right? So either I get a heart or I don't get a heart, right? So those two things sure to happen. It's a probability one, sure thing, right? Either I get a heart or don't get a heart. That's a sure, probability one, right? But the probability of getting a heart is 25%. So probability of not getting a heart is 1 minus 25%. You can say that's 75%. Okay? So that's one way of thinking about this problem. Another way to do this is going back to this definition here. Probability of getting not a heart, again, the total number of possible outcomes is 52. So I put that on the bottom. On the top, I don't want to get a heart. So out of 52, 13 cards are heart. The remaining 39 are not hearts. Either they are clubs or spade or diamond, right? So there are 39 cards. They are not heart. So I can just say that 52 is the total. 39 is not heart. That's what I want to put on the top. So 39 over 52. So that is actually 3/4, which is actually 75%. So you can think of this question either way, right? Whichever way that makes sense to you, you can do that, okay? So let's continue with this, the card problem. So let's say that from this 52, I'm taking one card, and I want to know what is the probability that it is a number card, okay? So now on the bottom, it's a total number of cards, that is 52, total number of possible outcomes. Then on the top, there are how many number cards? I need to count. There's no one. It's a 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 9 number cards, right? For each, the suite, right? So then 4 times 9, right? So that many number cards are there. So that is 36 out of 52, right? So 36 out of 52, so that is 69%. So either you can reduce it to lowest term, 9 over 13 fraction, or you can say that there's a 69% chance that I am going to get a number card, okay? So then another problem, if the question says, what is the probability that I'm going to get ace? Okay, I'm drawing one card. What is the likelihood that it's ace? So then if you use the definition, there are 52 possible outcomes. You want to write it at the bottom. That's the easiest thing to do. You do that first. And then how many aces I have? I've got 4 aces, right? Ace diamond, ace spade, ace clubs, and then ace heart, right? 4 of those. So 4 out of 52. So that is 1 out of 13. Or you can write it as decimal 0.0769, or you can write it as a percent, 7.69%. Okay, so you need to make sure that you remember what we covered before, fraction to decimal to percent, because in the test when they give you the answer choices for probability, they may either give you in terms of fraction or decimal or percent. So you need to know how to convert one to the other. That's very, very important. Okay? Okay. So now we said that it is, so now we know how to compute the probability. So now so then numerator, denominator, right? The top and the bottom. So that's what we need to do in every probability problem. So it's very, very important that we know how to count the total number of possible outcomes. So far, the dice and then the cards, it's very, very easy. Sometimes it's not going to be easy to get the total number of possible outcomes, okay? So we are going to do some counting principles, okay? So the basic counting principle or fundamental counting principle. So let's start with an example. So let's say that, I've got a sandwich store, and then I've got the bread. So for the sandwich, I need to have a bread, and I need to have cheese, and then I need to have meat. I need to have 3 things, right, to make the sandwich. So let's say for the bread, I have 2 types of breads, okay? So then it's the wheat or white. I've got 2 types of bread for you to choose from, okay? Then let's say I've got 2 different cheese. You can choose either cheddar cheese or Colby cheese. You can choose either one of those, okay? And then there are 2 types of meat you can choose, and that is either chicken or turkey, okay? So now the question is, how many possible sandwiches are there? Okay, so it's not a probability problem, so we want to do the counting principles explained so that if there is a probability problem, you know how to count the total number of possible outcomes, right? So in this case, what we are asking is, what is the total number of possible sandwiches? Okay, so now it's easy to visualize, so I'm going to draw a picture. So the first decision I need to make is I need to pick the bread. So the first if you go to any sandwich store, first thing they will ask you is Subway sandwich, they will ask, hey, what kind of bread do you want, right? So in this case, the first decision is either I have to choose wheat or I need to choose white. So they give you 2 choices. You pick one of those. That's the first decision point, the first attribute or first decision or first item, right? So I need to pick that. So once I pick that, and then the next choice I need to pick, what kind of cheese I want. I want the cheddar cheese or Colby cheese, right? I can pick either one of those. So far, you can see that I can pick wheat with cheddar or wheat with Colby, or white with cheddar, white with Colby. So I've got 4 possible choices of sandwich as of now, right? And then I can pick here the chicken or turkey. Here I can pick chicken or turkey. Here, chicken or turkey. Here again, chicken or turkey, right? So it's like almost like a tree. So when you look at this, you can see that I can pick wheat, cheddar, or chicken. That's one possible sandwich. Or I can do wheat, cheddar, or turkey. That's a second possible sandwich. or wheat, Colby, and chicken. That's a third possible sandwich. Wheat, Colby, or turkey. That's a fourth possible sandwich. Or I can do white, cheddar, and chicken. That's one possible sandwich. And white, cheddar, turkey. That's another possible sandwich. Or white, Colby, chicken, or white, Colby, turkey, right? So how many possible sandwiches are there? So if you just look at this tree, it's like a 1, 2, 3, 4, 5, 6, 7, 8, right? So I just went through the 8 possible choices. So there are 8 possible sandwiches, right? So the way it works, so this is an example. So what is the pattern we are seeing? So if I have to choose from 2 breads, and if I have to choose from 2 different cheeses, and if I have to choose from 2 different meats, we can see that the total number of possible choices is 2 times 2 times 2, so that is 8. Okay? So, we will do some word problems where you will be using these, so you don't have to actually draw the tree, so some problems may have a lot more than this too. So you don't want to waste your time in drawing the tree, but you understand that if you multiply the possible choices for each one, then you get the total number of possible choices, right? So in the test, you don't want to write down all these possible, the 3 choices thing, but all you have to do is multiply 2 times 2 times 2, 8, that's the total number of possible choices, okay? So that's one counting principle, and then there are 2 other counting principles, okay? So the next counting principle, it's called combinations, okay? So again, I'm going to use an example to explain that. So what do I mean by, combination, okay? So here, so let's say that I've got a bag of marbles, okay? I've got one red, one blue, and one yellow, and then one green, okay? Yellow, blue, and red. So I've got 4 marbles, right? And out of from 4, I'm going to pick 2, exactly 2 marbles, okay? So how many possible ways, how many combinations I can pick, right? So I can either pick, so there are 4 marbles, then I'm picking 2, okay? In the previous example, so you need to understand the difference. The previous example, the number of sandwiches, I have to pick 1 of each, right? So the bread, cheese, and meat. I have to pick every one of those. So the total number of possible combinations was the product, right? But in this case, out of the 4 marbles, I'm picking only 2. So whenever you are choosing 2 out of 4, then you have to use a combination. CC, remember, choose. You are choosing 2 out of 4, then you need to use the combinations. So let me explain how this works. So I'm choosing or picking, right? Choosing or picking 2 marbles, right? So either I can have a red, blue, that's one combination, right? I could have picked that, or I could have picked red, yellow, or I could have picked red, green, or I could have picked blue, yellow, or I could have picked blue, green, or I could have picked yellow, green, okay? So the way I do this, I use the red and blue, red and yellow, red and green, right? So those are these. And then I do blue and yellow, and then blue and green, that's what this is. And then I do yellow and green, right? Systematically, I write down all possible ways I can get those 2 marbles, okay? So these are the 6. So the total number of possible combinations is exactly 1, 2, 3, 4, 5, 6, okay? So from 4, I'm choosing 2, and that number is 6. That's what we got here, okay? So this is called the combinations, okay? And you do get combination problems, or you do get probability problems where you need to count this, okay? So then now let me explain, so it's very, very similar, the permutation, so I'm going to explain the permutation. So permutation also means that I'm picking, so permutation, okay. So here, so let's say that I have 4 dogs, okay, and the dogs, their names are exactly red, blue, yellow, green. So those are my dogs' names, okay. So again, I have red, blue, yellow, green. I have 4 dogs, okay? And these dogs participate in a competition, these 4 dogs. And then they are going to give a prize, first prize and second prize, okay? They are going to do that. So they are going to pick 2 dogs, and then one of them is going to get the first prize, another dog is going to get the second prize. Okay, so now how many possible winning sequences are there? So which, what are all the possible winning sequences, right? So here, the red, blue, so first prize, second prize. So the red dog wins the first prize, blue, second prize. Or it could be other way around. Blue gets the first prize, red gets the second prize, right? So in this case, the order doesn't matter. So I just have red and blue. So I'm just picking 2 marbles. Marbles, they don't compete. There's no competition for marbles. So I just got red and blue. But in this case, the red gets the first prize, or blue gets the second prize, or blue gets the first prize, red gets the second prize. So order does matter. So then, similarly, and then red, yellow, or yellow, red, right? Or I can have red, green, or green, red, or I can have blue, yellow, or yellow, blue, or yellow, green, or green, yellow. Okay, have I taken everything? Not yet, so I haven't done the blue-green part. So let me do that. Blue, green, and then green, blue, and then yellow, green, yellow. Okay, so now, because you can actually see that, right, the order does matter, so I'm counting red, blue, blue, red as 2 different possibilities, because that is true, right? First prize, second prize, red and blue, blue and red, first prize, second prize, so that does matter. So the red and blue is considered as 2 different sequences. But in this case, red and blue just 1, right? So in this case, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so there are 12 permutations. I'm picking, choosing, and then the order does matter here. Here I'm choosing, picking, but order doesn't matter, okay? So when order does matter, you are going to have a different number, even though I'm choosing 2 out of 4. Permutation, number of permutation is 12, but number of combination only 6, okay? So when you read the problem, you need to read it carefully. Does order matter or not? If order matters, you would do the permutation. Order doesn't matter, then you would use the combination, okay? So in this case, I've written it down, so it's very easy to see 6 and 12. But if you have, instead of 4 dogs, let's say I have 20 dogs, then how do you do that, right? So there is a formula, just like the sandwich example. You don't need to write down all the tree. You just multiply the possible numbers for each one of those ingredients, then you get the total number. You just product. Similarly, here there's a formula for combination, there's a formula for permutation. It's a little bit complicated. So let me explain that, okay? So the total number of possible combinations is always, the total number of the possibilities, right? The red, blue, yellow, green, total number of marbles, the total number of things, that's always n. And whatever you are choosing, that's always k, okay? So from n marbles, I'm choosing k marbles. And similarly here, so this the n dogs, and you're choosing k dogs, but the order does matter here, right? So that's usually we use n and k. And then there is a formula for that, the combination. So the number of combinations, C, equals and it is n, n minus 1, n minus 2, and so on, and then divided by 1 times 2 times 3 and so on. Okay, and here the number of permutations is, it's n, n minus 1, n minus 2, and so on. Okay, so I've given you the exact formula, here, but it's kind of looks complicated, so let me explain that. So all you have to do is, if you want to find the number of combinations, so what you have to do is, on the top, so you've got the top and the bottom. On the top, excuse me, so you will always start with n. N is 4. You always start at n, and then you need to go 1 down. If n is 4, and then you do n minus 1. So from n is 4, the next one 3. You will always subtract 1, right? You do that on the top. On the bottom, you will always start at 1, and then you will add 1. 1, 2, 3, 4, like that. You will be adding 1 at a time. And then how far do you go? If I'm picking only 2, you stop at these 2 numbers. And then in the bottom 2 numbers. So you always start with n and then keep going down by 1. And then how long do you go? If k is 2, you go only 2. Okay? If k is 3, then you would have gone 4 times 3 times 2 on the top. On the bottom, 1 times 2 times 3. Always you'll have 2 numbers on the top, 2 numbers on the bottom. Always on the bottom you start from 1 and then you keep going up by 1. On the top you start with n and then you keep going down by 1, and then you multiply all the numbers on the top, multiply all the numbers on the bottom. Okay? So now you can actually see that in this case 4 times 3, on the bottom 1 times 2, so the 2 goes 2 times, so 2 times 3 is 6, and that's what we got, right? So that's what exactly we got before. Okay? Similarly here, the permutation, you just need to do only the top. There's no bottom on the permutation. On the top, you do n, so that is 4, then times, and then you go down by 1, 3. Then if you pick 2, then you got 2 numbers, you just stop. 4 times 3, that is 12, and that's what you got. Okay? So if k equals 3, then you would have gotten like 4 times 3 times 2. 3 times you would have gone. Okay? So, so that's the formula. So you don't need to actually write down all possible things. If there's a small problem like this 4 and 2, you can write it down. But if the numbers n is big, you won't be able to write it down. Then you can actually use the formula and then compute that. Okay? Okay, so with that, we have pretty much covered the basic statistics, data summary, graphs, and plots, and then the probability, and then the counting principles. We are done with all these. So now what we are going to do is, we are going to put it all together. We've got a lot of word problems. There are several word problems here, so I'm going to do those word problems, okay? So let's start with problem number 1. It says that annual precipitation at Unicity, Rapid City, Apple City, and Orange City, 4 different cities. Annual precipitation means annual rainfall, right? It says that R, 3.5 inches, 4.8 inches, 4.2 inches, and 5.1 inches. 4 different cities, and then these are the 4 precipitation values. And the question is, what is the mean precipitation? Okay, the mean or the average. So all you have to do is, you need to add the 4 numbers. There are 4 cities, so there are 4 numbers, right? And then divide by 4, and that is 4.4 inches. So I can say that on an average, the annual precipitation in these cities is 4.4 inches. Okay? And then the second problem, it's asking what is the median precipitation. Okay? So the first thing we need to do, whenever you do the median, you need to remember I need to put the data in order, okay? So you want to put the lowest number first, 3.5, the next is 4.2, the next is 4.8, and then next one is 5.1, okay? So median is defined as the middle value, right? So in this case, there are 4 data points, right? So even numbers, the middle is somewhere in the middle here, right? Somewhere in the middle right there. So then how do I compute the median? So then what you have to do is to take these 2 values, so there's a middle, this is where the median is, you take these 2 data values, take 4.2 and then 4.8, right? And then you just take the average of those 2. So you just take 4.2 plus 4.8 divided by 2, average of 2 data points, and adding the 2, divide by 2, adding those 2 numbers, divide by 2, and that comes out to be exactly 4.5. So the median rainfall, annual rainfall, or median annual precipitation is 4.5 inches. So you see the mean is 4.4, the median is 4.5. So the mean and median don't need to be exactly the same, they could be different, okay? Okay, so the next one, so we saw before, if there is one middle value in the data, that will be your median. But if there is no one middle value, 2 middle values, then you need to take the average, okay? So then do the next problem, number 3. In a company's annual party, 500 employees bought raffle tickets, okay? John, Sam, and David bought 4 tickets each, okay? What is the probability that one of them will win, okay? You want the probability that one of them to win. So that probability, so the first thing is you want to draw a line. You need to decide the bottom and the top, right? The bottom is the total number of possibilities. There are 500 employees, they bought tickets. So there are 500 people, 500 tickets, any one of them can win, right? So total number of possible tickets is 500, okay? On the top, it says that John, Sam, David, each one bought 4 tickets. So John got 4, Sam got 4, David got 4. So there are 12 tickets together, right? So there are 12 tickets together. So the number of favorable tickets is 12, any one of those 12, right? So you put that on the top. So 12 divided by 500, so that's a probability. Then you can express it as a fraction, 3 over 125, or as a decimal, 0.024, or you can say 2.4%. So the probability that John, Sam, or David, they will get they will win is that 12 over 500. So either you can express a fraction or decimal or a percent like this, 2.4%. Okay? So roughly, in this case, so let me give you a little hint here. So whenever it says or, so either John or Sam or David, right? What is the probability that one of them will win? Either John or David or Sam, right? So either or, if that's the case, then you will be adding those outcomes, right? The 4 plus 4 plus 4, because any one of them, either or means that any one of the 12. That's what that means, right? So the key word is either or means that you'll be adding those outcomes, okay? So now let's do the next problem. Okay, problem number 4. And there are 7 blue balls and 8 red balls in a jar. So immediately you need to write it down, 7 blue and then 8 red in a jar. And if you draw 2 balls with replacement, so you are taking a ball, look at the color, put it back, taking the ball again, look at the color and put it back, okay? So if you draw with replacement, what is the probability that both of them are red, okay? So now, so whenever you have, this is called, first you are taking a ball, look at the color, put it back, okay? And then you are taking another ball, look at the color, put it back. So there are two independent actions, two independent events, right? So whenever that happens, the probability, when you have like two independent events, probability of A and B, the key word is and, is probability of A times the probability of B, okay? So in the previous case, either or means you are adding the events or adding the probabilities, but and means that you are multiplying. So let me explain why that's the case, okay? So the first, so let's say I'm taking the first ball, okay? So let's compute the probability that I'm getting the first red ball, okay? So the probability that I'm getting a red, first one, okay. So write down, first put the line. On the bottom, I'm just taking 1, right? The total number of balls is 15, that's on the bottom. On the top, 8 of them are red. So the probability that I'm going to get a red is 8 out of 15, right? Just like the way the die and the coin problem we did. So the first one is red is that. So then I'm looking at the color and then I just put it back there. So then the second time I'm taking another ball, and then the probability that the second one is red, again, in the jar, again there are 15 balls and then 8 of them are red. So again, it's 8 out of 15. So now the probability that I'm getting a red and then a red, what is the probability that I'm getting this and that? So then that is 8 over 15 times 8 over 15. So the probability that you get red in the first time and the red the second time, so whenever the key word is and, you need to multiply the two probabilities, okay? And that comes out to be 0.28, or you can say that it is 28%, okay? So whenever you are computing the probability of two independent events happening, then you just multiply the two probabilities, okay? So now the next problem, so problem number 5, if you draw the two balls without replacement in the same question, what is the probability that both of them are red? Okay, without replacement. So I'm just taking a ball, and then I got something, put it aside, and then I reach out, get another ball. I'm not replacing it, right? So the probability that I'm going to get so the question is, what is the probability that the both of them are red, right? So the probability that I'm going to get that red in the first shot is same as before, right? The total is 15. And now 8 red balls, so 8 out of 15. So that the probability that the first one is red is that, right? Then the probability that the second one is red, so now you need to remember, I didn't put it back. I just took a ball, put it aside. Now, how many is left over in the jar now, right? Now, there are only 14 because I've already taken one, put it aside, right? So now, now 14, and then the first one is, if I've taken the red out, so then how many red remaining, right? So instead of 15, now it is 14. Then in the first time, I've already taken the red out and put it aside. Remaining, I've got only 7 red, so 7 out of 14, right? So 7 red balls out of 14. So now, what is the probability that both are red, right? So now, again, first one is red and the second one is red. Again, I just need to multiply 8 over 15 times 7 over 14. So now you see that if I replace it, the second one was 8 over 15. If I do not replace it, 7 over 14. So you need to remember that, right? So then when you compute this comes out to be 0.267. So this is a different number, 26.7%. Okay? So, so this you can actually intuitively, common sense, the first one, if I replace it, the ball, 28% chance that both are red. But here, I didn't replace it, so it's only 26%. So you expect a little bit lower likelihood or probability. That's what is happening, right? Okay, so that's the next problem. So you need to think, either or means adding, and means you're multiplying. And then you need to read the problem, whether it's with or without replacement. So each probability, you need to compute this one and that one accordingly, right? So it could be different. Okay, so now let's do the next one. Problem number 6. It says a club has 20 members and one person needs to be chosen as president, one as vice president, and one as a treasurer. How many possible ways 3 positions can be filled? Okay, so you need to think, okay, whenever they ask you these kind of questions, there are 3 counting principles we talked about. The first one, the basic fundamental principle, and then combination and permutation. So in this case, there are 20 members, so n equals 20. Out of those, 3 people need to be chosen for the 3 positions. So you are choosing k equals 3. You're choosing, okay? And then here, president, vice president, treasurer, right? So it's going to make a difference. So the order does matter. So if I've got 3 people, Bill, Bob, and Mary, so one may be the president, one may be the vice president, one may be the treasurer, or this person may be the VP, this may be this treasurer, or this could be the, all these different possibilities, like the dog example I showed. So I will be counting Bill, Bob, Mary as one possibility like this, president, vice president, treasurer, or vice president, president, treasurer, and so on. So order does matter. So the first thing you need to find out is there a total number of people? Am I choosing a subset, smaller number out of that? That's the first question. If that's the case, then it's going to be either combination or permutation. So first, it's n equals 20, and then k equals 3. So it's going to be either permutation or combination. And then I need to ask the question, does order matter or not? The order does matter because there are 3 different positions. So then you need to realize that this is a permutation problem, okay? Then the permutation problem, so number of permutations, I said using the formula. So there is no top and bottom, there's only top in the permutation. So it's always, you will start with n, so in this case, 20, okay? And then you multiply 1 down, so 19, right then. And then you will go 1 more down, and then you just stop, k equals 3, then you stop right now. So I start with 20, and then 19, then 18, stop, because k equals 3, okay? So when you multiply 20 times 19 times 18, that comes out to be 6,870 possible combinations, or 6,870 different permutations, okay? So, so once you look at the keywords, then it should be very obvious to you which formula to use. So let's do the next one, number 7. There are 5 math books, 8 science books, 7 music books. A teacher has to choose 1 math book, 1 science book, 1 music book for her class. How many possible combinations are there? Okay, so 5 math book and 8 science book and 7 music book, okay? And she needs to pick 1 of each. So the key word you need to remember, in the sandwich example, you have to choose a bread, you have to choose the cheese, you have to choose the meat. You have to choose 1 of each, for sure. Similarly, she has to choose 1 of this, 1 of this, 1 of that, okay? But on the other hand, in the marble example or the other club member example, there are 20 members, and then 20 members, you are just picking 3. So in the 20 members, We didn't have like a math and music and science, we didn't have any of those, right? So that's why, that is a permutation or combination problem. In this case, we've got 5 math, 8 science, 7 music books. So we've got 3 different kinds, and you have to pick one of each, right? So one from each. So how many possible combinations? So here, it's very, very similar to the sandwich problem. So the total number of possibilities is 5 math books, and with every math book, the teacher can pick any one of those 8 science books. That's why it's 5 times 8. Then with that combination, then the teacher can pick any one of those 7 music books. That's why the tree thing, you see the times 7. So then when you multiply these, there are 280 different possibilities, possible combinations, okay? So that's the 7th problem. And then the next 3 problems are based upon this, picture here. Okay. Let's go back and look at the picture here. So let me show you the picture. So the pie chart here, you may want to look at in your booklet. So in this pie chart, so we've got A, B, C, D, the percent of students who got the different grades. Okay. So then, when you look at this pie chart, the question is what grade about 1/3 of the class received? That's a question. So when you look at the pie chart, right? So it's very difficult for me to draw. So this is A, B, C, D. And the percent-wise, this is about 14%, this is about 42%, this is about 35%, this is about 7%, right? So the question is, what grade about 1/3 of the class received? So about 1/3 means what? About 1/3 means, if you put it in decimal, so again, you need to know that if you put in decimal, it's 0.33, or if you put in percent, it's 33%. So that's what 1/3, right? So very close to 33% is what? It's 35%. So your answer is this. Okay. So about 1/3 of the class received the grade C, right? So that's the answer. And so the reason these things are very important, so we talked about the probability so far. So if they give you this chart and say that, okay, so another way of saying this, about 35% of the students receive the grade C. Okay, so that's one way of saying that. Another way of saying this is, from this class, if I pick one student at random, what is the probability that that student is going to get a C? Okay, so if I have a probability problem, so then how do I do that? So then on the bottom, I will have the total number of students in the class, which is 12 plus 4, 16, 16 plus 10 is 26 plus 2, 28. So if you count the total number of students in the class, it's 28. Then on the top, how many people got exactly C? 10 students, right? So if I pick one student from the class, what is the probability that that person is going to get a C? You would put 28 on the bottom, 10 on the top, 10 over 28, that is exactly this 35%, right? So that's what the pie chart says. So the pie chart, when it gives you the percents, you can look at the percents in 2 different ways, right? So you can either say 35% of the class received a grade of C. That's one way of saying that. Another way of saying that if I pick a student randomly from the class, what is the probability that he's going to have a C grade? 35% probability. So it means the same thing, okay? So that's how these you can see how you can tie the graphs and charts with probability, okay? So the next problem, so look at the next chart here. So this is the the frequency chart here. So what percent of the class had 4 or 5 marks, okay? So if you look at that problem, so again, so what percent of the class got a mark of 4 or 5? So if you look at there are totally 26 people in the class. Out of that, 5 students got a mark of 4 points, or 4 marks, and 3 students got a mark of 5 points, score, or points, or mark 5, right? So 8 students got 4 or 5 score, and then 8 of 26. So that is about 30%. Okay. So again, so you can answer the question: 30% of the class got either 4 or 5 marks, or I can say that if I pick a student at random from the class, the probability that student has got either 4 or 5 score is 30% chance that that person is going to have a 4 or 5. Okay, so that's another way to interpret that. So then the next problem, so let's go back to the last chart here. So this is the histogram that we covered before. This is the reaction time for teenage drivers. Okay, so that's that chart here. And which percent of teenagers' reaction time is more than 0.7 seconds, okay? So again, you go back to the histogram. So there is a histogram here, like that, and then like this, okay? And then here it's 0.25, and then 0.7, 0.7 in the middle, 0.55. And the question is that what percent of the teenager's reaction time is more than 0.7, okay? So more than means you got 0.7, so more than means on the right hand side. So there is one person here, 1. So there are 2 people whose reaction time is more than 0.7, okay? And before we did that, if you count the number of teenagers in this chart, it was 35 people. So 2 people out of 35 people had a reaction time of more than 0.7 seconds, okay? So the percent is 2 out of 35, which is 3.7%. So another way to say that is, there's one way to say that 3.7% of the teenagers, the reaction time is more than 0.7 seconds. Okay, so that's one way of saying that. Another way of saying that is that if I pick one teenager, what is the probability that that teenager's reaction time is going to be more than 0.7%? So that probability is 3.7%. Okay? So with this, we have completed step 3, and then the next session we will cover algebra. Okay?